Hi guys, it's me UBprogrammer and welcome to the lecture 3 of Digital Logic Design series. And tools complement is more efficient than the signed representation. I just want you to know that you can download these notes from the description, right? What this line means is that if you are limit to use, and if you are bound to use the negative numbers, so go with the two's complement. It is more efficient and it is quick than the signed representation, which is like adding a bit, right? So the two's complement will always give you correct result in the case of negative and other numbers, right? Okay, and a concept is being introduced as the overflow. So what this concept says that if a number is too large to represent, then we say that the system is overflowed, right? And so to deal with it, we use floating point notation, right? So we just multiply 10 to the raised to power something, right, to represent really large or really small numbers. Let's see a floating point notation, which is 32-bit floating point notation, and it is the same concept. If you are wondering that your system is 32-bit or 64-bit, so it's all coming from here, right? So in the 32-bit system, the first bit is reserved for the sign of the number. Then the next 8 bits represent the exponent part, like 10 to the raised to power something, so that part will be deal with here, and 8 bits are reserved for that, so you can assume quite big exponent can be dealt, right? Then the remaining 23 bits represent the fraction part, the mantissa, you can always say that. Okay, so that's how the 32 bits completes here, right? Let's see the magnitude and the exponent of this number. So it is a floating point number. Then we will make the exponent of this number as 10 to the raised to power 3, and the exponent will be 3, and the magnitude will be this number without this floating point. Then there is a system, hexadecimal system, which is 16 base 16 number system, and why we use that system is to represent really long binary strings. So if the binary number is really big, there will be a great chance to mess with that, because writing them down will be quite a nightmare, right? So we use this hexadecimal number because every digit in the hexadecimal represent 4 bits of binary, right? So FD13 represent this large string of binary numbers, right? So that was it for this lecture, and I will see you in the lecture 4 of this series. Thanks for watching.